So welcome Senior Chemistry to the next topic, energy changes. So our learning outcome by today is that by the end of the lesson you should be able to identify the exothermic and endothermic reactions using either energy diagrams, delta RH values, which we'll go into in more detail if you don't understand what those terms actually mean, and heat changes. So one of those words probably you didn't quite understand is enthalpy. Now, enthalpy is the heat content of the substance, essentially the potential energy locked in the bonds of a substance, and it can be released obviously either by, say, burning it or by chemical processes. The symbol is a capital H, and the units are kilojoules because it's a measure of energy. And the enthalpy change, or delta RH, where R, the little r there, stands for reaction, is the enthalpy of the products, or the H of the products, minus the enthalpy of the reactants. So these systems, or these processes, can be graphed, as we can clearly see here. Okay, and we have an exothermic graph for an exothermic process and a graph for an endothermic process, as we can clearly see there. Okay, so in the exothermic process, the amount of energy in the reactants is greater than the amount of energy locked up in the products. Therefore, the change in enthalpy is going to be negative. That means that heat is being released into the surroundings. However, for an endothermic process, which is the one at the bottom, the amount of energy in the bonds, locked in the bonds of the reactants, is less than the amount of energy locked in the bonds of the products. So that means you've got heat being absorbed from the surroundings, which is then placed in the products, in the bonds of the products. So delta H, or the change in enthalpy, is positive. So let's now look at exothermic reactions. Okay, so in exothermic reactions, reactants have more energy than the products. This means that an exothermic process releases energy, like striking a match, and the temperature of the surroundings increases because energy is being released into the surroundings. It means if you have a test tube which is undergoing an exothermic reaction, it feels warm because your hand is detecting the heat being released by the reaction. There is a negative enthalpy of reaction, or change in enthalpy of reaction, because you've got the formation of bonds. Okay, so the energy is being released and bonds are being formed. However, on an endothermic process, reactants now have less energy than their products, which means you're getting absorption of energy from the surroundings, so the temperature of the surroundings decreases. That means if you have a test tube which is undergoing an endothermic reaction, it's going to feel cold. So this time there's a positive change in enthalpy of reaction, and that also means that you're breaking bonds because it requires energy to break bonds to form these new products which have higher energy. Okay, so let's look at an example. And the example we're going to show is the sublimation of carbon dioxide and whether it is an exothermic or endothermic process, and why it's an endothermic process. So in the sublimation of carbon dioxide solid, or dry ice, transforms into carbon dioxide gas without going through a liquid phase. Okay, so to break the weak intermolecular forces between the carbon dioxide molecules requires energy. Remember from our previous learning that it's very strong intramolecular bonding in carbon dioxide, but very weak intermolecular bonding. And breaking these bonds does require an amount of energy. There are no weak intermolecular bonds between carbon dioxide gas molecules because they're so far apart, so no bonds form, so there's no energy released because that would be the exothermic component. So overall, since the energy into the system is greater than the energy out, it's an endothermic process because delta H, or the enthalpy, or change in enthalpy, is positive. There's more energy in the products than there is in the reactants. So if a reaction is endothermic in one direction, it will be exothermic in the opposite direction. So in the previous example, if you transformed carbon dioxide gas back into carbon dioxide solid, that would actually release energy and you get an increase in temperature. Okay, so in this example, we'll just with letters, if A plus B going to C plus D is an endothermic process, then the corresponding reverse reaction of C plus D going to A plus B would be exothermic. And that is enough for today's lesson.